Welcome to this lesson on relative formula mass. In today's lesson, we will firstly introduce relative formula mass. We will then understand conservation of mass in a chemical equation with regards to relative formula mass. So far, you have learned about the conservation of mass, which states that mass is neither created nor destroyed in a chemical reaction. You are also familiar with the concept of relative atomic mass, as well as how to balance chemical equations. Today, we will extend upon this foundation and deepen our insight into how the mass of reactants and products remains consistent in chemical reactions. Let's delve into the concept of relative formula mass, known as MR, and how it can tie in with the conservation of mass in chemical equations. The relative formula mass of a compound is the sum of the relative atomic masses of all the atoms present in the compound, as indicated by their chemical formulae. Since the actual mass of compounds is very small, this is a relative mass. It represents the average mass of a formula unit of the compound in comparison to the mass of a carbon-12 atom, which is assigned a relative atomic mass of exactly 12. For example, if a certain compound weighs double a carbon atom, then it would be assigned a relative formula mass of 12 multiplied by 2, which is equal to 24. To calculate the relative formula mass of a molecule, we need to follow a series of steps. For example, let's calculate the MR of water. First, we must determine the chemical formula of the compound. The chemical formula of water is H2O. Now we need to find the relative masses of each element in the molecule from the periodic table. These are usually listed above the element symbol. Hydrogen has a relative atomic mass of approximately 1, and oxygen has a relative atomic mass of approximately 16. Finally, we will multiply the relative atomic mass of each element by the number of atoms of that element in the chemical formula, and sum these values to obtain the relative formula mass. In H2O, there are 2 hydrogen atoms and 1 oxygen atom. Therefore, the relative formula mass of water is 2 multiplied by 1, which is 2, plus 1 multiplied by 16, which is 16. 2 plus 16 is equal to 18. We can use this new knowledge of relative formula mass to demonstrate the law of conservation of mass. Let's consider a balanced chemical equation. 2H2 plus O2 creates 2H2O. First, we find the MR for each molecule involved. For H2, we have 2 times 1 equals 2. Next, for O2, we have 2 times 16 is equal to 32. And finally, for H2O, we have 2 times 1 plus 16, which is equal to 18. Next, we must consider the coefficients in our balanced equation. Let's first consider our reactants, 2H2 and O2. We know that the formula mass of H2 is equal to 2. Next, we know that the formula mass of O2 is equal to 32. So, to find the relative formula mass of our reactants, we need to add 4 plus 32, which is 36. Therefore, the relative formula mass of our reactants is equal to 36. Now, let's look at our product, 2H2O. We know that the formula mass of H2O is equal to 18. So, the relative formula mass of 2H2O is equal to 18 multiplied by 2. Therefore, the relative formula mass of our products is 36. In this way, we can see that the total mass of the reactants is equal to the total mass of the products, demonstrating that mass is conserved in this chemical reaction. Let's go through some examples to apply our understanding of relative formula mass. Question 1. Calculate the relative formula mass of sodium chloride. Pause here to have a go yourself. Let's go through the answer. Step 1 is to identify the relative masses of sodium and chlorine from the periodic table. The relative mass of sodium is 23, and the relative mass of chlorine is 35.5. Now, we must determine the number of each type of element in the formula. Sodium chloride has one sodium ion and one chlorine ion. Finally, we must calculate the relative formula mass by summing up the relative masses of all the atoms in the formula. The relative formula mass of sodium chloride is therefore equal to 1 multiplied by the relative mass of sodium, which is 23, plus 1 multiplied by the relative mass of chlorine, which is 35.5. This makes the relative formula mass of sodium chloride 58.5. Let's move on to a slightly more complex example. Question 2. Calculate the relative formula mass of calcium carbonate with the chemical formula CaCO3. Pause here to have a go yourself. Let's go through the answer. Step 1 is to identify the relative masses of calcium, carbon, and oxygen. The relative mass of calcium is 40, carbon is 12, and oxygen is 16. Now, we must determine the number of each type of element in the formula. Calcium carbonate has 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. Finally, we must calculate the relative formula mass by summing up the relative masses of all the atoms in the formula. The relative formula mass of calcium carbonate is therefore equal to 1 multiplied by the relative mass of calcium, which is 40, plus 1 multiplied by the relative mass of carbon, which is 12, plus 3 multiplied by the relative mass of oxygen, which is 16. This gives us 40 plus 12 plus 16, multiplied by 3, which is equal to 100. This makes the relative formula mass of calcium carbonate 100. In today's lesson, we delved into the concepts of relative formula mass, which is the sum of the relative atomic masses of all the atoms in a chemical formula. We then practiced various examples of calculating it. This concept is crucial for quantifying substances in chemistry and will be an essential skill as we introduce more complex topics in quantitative chemistry.